Hi everyone, welcome to my talk. I am Umair from Lancaster University and I am going to present our paper ThermoPixels Toolkit for Personalizing Arousal-based Interfaces through Hybrid Crafting. The co-authors of this work are Corina and Miquel Alfaras. I will start by highlighting the motivations behind this work. Then I will cover the aim of the research, followed by introducing ThermoPixels Toolkit, explaining our method and findings. Finally, I will highlight key takeaways. The motivation of this work comes from affective interfaces providing interactive feedback on physiological signals. Affective feedback on physiological arousal can help engage in self-reflection and increase emotional awareness and regulation, which both are fundamental skills for emotional well-being. Most existing systems are given to the users as ready-made black box devices. However, there are strong benefits from involving users in the design of such technologies, which include agency, personalization, adoption and attachment to the device, as well as understanding of technology's inner working. Our work aims to personalize effective interfaces for physiological arousal by involving users in the design process. We do so by designing ThermoPixels, a toolkit which contains both digital and physical materials. We wanted to understand how do less technical users explore and understand the toolkit material qualities. How is the toolkit used to create personalized representations of arousal and how are these experienced? And what's the value of ThermoPixels toolkit for effective interfaces design? To design the toolkit, we built on our previous work articulating key qualities of thermochromic materials. Thermochromic materials change color when heated, they are low cost and easy to fabricate. They require a heating layer underneath to change color and an insulation layer to protect from the heat. To design ThermoPixels, we engaged in hands-on exploration of thermochromic materials, different heating and insulation materials, as well as skin conductance sensors. Its basic components include thermochromic sheets and paints, different heating materials including heating pad, nichrome wire, Peltier element, and conductive fabric, insulation to safeguard from the heat, galvanic skin response sensor to measure arousal levels, and supporting tools. To evaluate the toolkit, we conducted hands-on workshops with 20 people with diverse backgrounds. Each workshop session consisted of three main parts. In the first part, participants were introduced to arousal. Secondly, they were introduced to the thermopixels, after which they engaged in exploration of its components to understand their properties, and then building working prototypes. Finally, participants were shown a set of images to elicit arousal, where they could observe real-time actuation of their developed prototypes, followed by individual interviews. Our findings highlight four important aspects of thermopixels: exploration of its materials and how this impacted the design and building process, motivations for designing the interfaces, how the toolkit guided the meaning-making process, and their experiences of personalization. Most thermochromic materials could be activated close to the body temperature. Participants use this affordance to actuate them by a range of bodily interactions, such as placing hands on them, tapping them, holding and pressing, rubbing, or even blowing warm air onto them. These interactions offered an opportunity to experiment by observing the impact of bodily interactions onto the change of color. On the other hand, different colors of paints were combined together to create new ones. The change of color through paints tended to be slow, involving uneven color patterns with blurred boundaries, of limited brightness and resolution. While the thermochromic colors offer the visible layer, the heating materials are concealed, playing a key role in the pattern and the shape of activated colors, as well as their temporal unfolding. Participants connected them to the battery terminals, played with both minor and large changes of current in order to watch its impact on the colors, their speed, and movement patterns. Both the heating pad and the fabric are soft, textile-based materials, so they can be easily bent and shaped. As a result, participants created shapes out of the fabric by cutting it, while realizing the surface area of the fabric determines how quickly it heats and cools down. An important finding is the two distinct motivations for designing the interfaces, which is for awareness and for regulation of high arousal. Participants used both heating materials and colors to create angular shapes and warm colors to signify an increase in arousal. Other than red and angular shapes, participants used patterns of mixed colors to represent increasing of arousal. Participants 8, for example, used mixed colors combined with small dots of different colors on top of the fabric. As a result, when the fabric slowly heats up, it creates an interesting mix of animating colors symbolizing more. The second group of prototypes were created using round shapes, cool and muted colors, and light patterns. The use of round shapes, cool and muted colors, and light patterns, aided by the slowness of thermochromic materials and coupled with in the moment interaction, were meant for decrease of high arousal negative emotions. The toolkit successfully guided the meaning-making process for understanding of arousal and exposed the material challenges with respect to responsiveness. By working with and experiencing the toolkit materials, participants develop a richer, visceral understanding of arousal and its decoupling from the valence. Since individual colors are more likely to be associated with discrete emotions, participant 10 decided to avoid individual colors and instead used a color mixture. Participants understood the limitation of materials after understanding how they work. Finally, participants' effort to personalize arousal representations contributed to the attachment with their designs, increased agency, and understanding of inner working. Participants' 14 investment of injecting personal meaning and expression of self was particularly interesting. And I quote, I think it was empowering because really emotions are real, totally subjective things. The whole process of decision making was for me. I feel this was kind of embodiment of myself, how I approach my emotions. Now I will highlight important takeaways for you. Toolkits have been studied as the creation tools for engagement and attachment to handmade artifacts, allowing people to assemble their components according to step-by-step instructions. We propose that toolkits should allow for open exploration of its materials and their affordances, which can lead to creative expression, potentially through bodily engagement. This type of engagement can help understand potential limitations of the materials in a richer and embodied way. Participants in our study wanted to use interfaces for emotion regulation. Emotion regulation is the ability to exert control on one's emotional state. However, its future use in the design workshops should involve taking further steps in sensitizing participants to the challenges and the benefits of each of these skills in the context in which the effective interface are to be designed for. Participants became aware of the material limitations during the building process, which means participants could question the prototype actuation, which is either triggered through physiological arousal or because of the material limitations, giving them authority over the interface. We propose that future work on effective interfaces developed by less technical users should also encourage a thorough exploration of their affordances and limitations before they are deployed in everyday life, to create a space for open critique and effective sense making. With this, I would like to thank you for your attention. In case of any questions, feel free to contact us.